Hey there, pre-cal. Alright, so we're still working on vectors. So last time in 6.3e we talked about how we can view unit vectors as vectors that land on the unit circle and how this is all related to sine and cosine, how sine and cosine can help us find a direction angle. Today what we're going to do is we're going to look at that from the opposite direction. So what if they tell me the direction angle? What if I know what direction my vector is going and I know how long my vector is? Can I find it? And the answer is yes. So we're going to go the other direction today. Before they gave us the vector in component form and we found its direction. Now they're going to give us the direction and we're going to find components that meet this criteria. So here's example 1. We're going to find component form for some vector v if the magnitude of v is 5 and it's going in the direction of 130 degrees. Okay, so let's just think about that 130 degrees for a minute. If we are thinking about our unit circle, 130 degrees, well, this is 90, right? This is 180. And so if we think about those three angles we know inside here, this one is 120. And this next one is 90 plus 45, which is 135. So right away you can see this 130 is not one that you have memorized. It's still on the unit circle, it's just not one you have memorized. So that tells me that I'm going to need my calculator to get precise measurements here. Alright, so we've got a magnitude and we've got a direction. How do we build V? Well, what we noticed yesterday was that we can view this magnitude as a scalar, and then we can use sine and cosine with our direction angle. And so if I want to build the components for V, I'm going to use that magnitude as the scalar, 5, and then the x-coordinate is going to have to be cosine of 130 degrees. And the y component is going to have to be 5 times sine of 130 degrees. And so if I put 5 cosine 130 and 5 sine 130, making sure I'm in degree mode now, I get that this vector, let's round those long ugly decimals to 3 places like we always do. Sorry, that was really ugly. Negative 3.214 and 3.830. At this point, I usually check my signs and make sure I knew that landed in the second quadrant, and this is also landing in the second quadrant. So that helps me feel like my answer makes sense. So this would be component form for that vector v. So this vector has a magnitude of 5 in the direction of 130 degrees. All right. So what if we want to do a linear combination? So now I've got two vectors. I've got a vector u whose magnitude is 5 going in the direction of 90 degrees, so it's going straight up the y-axis. I've got another vector v whose magnitude is also 5 and it's going in the direction of 60 degrees. I want to find the component form for the sum of those two vectors. Alright, so the first thing I'm going to do is I'm going to build these vectors in component form and then I'm going to add them together. These are nice measurements on my unit circle, so I have memorized values for 90 degrees and 60 degrees, so I'm not going to need my calculator for this one. Okay, let's look at u first. U is going to be a magnitude of 5, cosine at 90 degrees, a magnitude of 5, sine at 90 degrees. Well, what is cosine at 90 degrees? 0. So 5 times 0 is 0. And what is sine at 90 degrees? Well, that's 1, so this is 5. Let's just step back for a second and think about this answer. Wouldn't 0, 5 have a magnitude of 5, a length of 5, and a direction angle of 90 degrees, wouldn't it go straight up that y-axis 5 units? So the answer we're getting makes sense with what we know about just graphing in general. Alright, let's look at vector v. So we're going to have 5 cosine 60 degrees. We're going to have 5 sine 60 degrees. Alright, so 60 degrees. That's this one on your unit circle, right? So what is that ordered pair on your unit circle? You can still use your little hand trick. That means you're going to have your index finger down, so you're going to have 1/2 and root 3 over 2. So we're going to have 5 times 1/2 and 5 times the square root of 3 over 2. So that's, I'm just going to write 5 over 2 and 5 root 3 over 2. Okay, so now I can find my sum. So u plus v is 0.5 plus 5/2, 5 root 3 over 2. Alright, so 0 plus 5/2 is 5/2. It's easier to add these together if I have a common denominator. So if I've got 5 and I've got 5 root 3 over 2, my common denominator is going to be 2. So I'm going to write that next piece as 10 over 2 plus 5 root 3 over 2. So if I was going to leave this in radical form, I would write 5 over 2 and 10 plus 5 root 3 over 2. Of course, if they ask for a decimal answer, that could go into your calculator. If you put that in your calculator, 5 over 2 is obviously 2.5. And 10 plus 5 root 3 over 2, in my calculator, I'm getting 9.330. Alright, so that's what you're going to do in your homework for 6.3F. They're going to give you a magnitude and a direction, and you are going to write the vector in component form, and then just 2 or 3 problems where you have to build the vectors yourself and then do a linear combination of them, do some operation between them. Hope all's going well. Don't forget that I am just an email or a phone call or a text away. If there's anything you need, please don't hesitate to ask. I am super happy to help out. I want to be sure you guys are getting whatever you need, whether that be a video chat or just a quick text or whatever. I'm here to help. Reach out if you need me. Talk to y'all soon.